Next is condensation reactions of aldehydes and ketones. Condensation reactions. Condensation reactions of aldehydes and ketones. The first one is aldol condensation. Aldol condensation. Aldehydes and ketones having alpha hydrogen atom, when treated with dilute alkali, will undergo self-addition reaction to give beta hydroxy aldehydes or beta hydroxy ketones, and this reaction is known as aldol condensation. So aldol condensation, when aldehydes and ketones having alpha hydrogen atom is treated with dilute alkali, will undergo a self addition reaction to give beta hydroxy aldehyde or ketone. Beta hydroxy aldehyde or beta hydroxy ketone. So this is what is aldol condensation. When aldehydes and ketones having alpha hydrogen atom is treated with dilute alkali, will undergo a self-addition reaction to give beta hydroxy aldehyde or beta hydroxy ketone. So aldehydes and ketones having alpha hydrogen. Example, acetaldehyde CH3CHO. What is the actual structure of acetaldehyde? CH3 C double bond OH. As we discussed earlier, CO group attached carbon. This carbon is alpha carbon, and therefore these hydrogen atoms are alpha hydrogen. So this type of aldehydes or ketones having alpha hydrogen atom, when treated with aqueous alkali, dilute alkali, that means CH3CHO, when treated with dilute alkali, dilute NaOH or KOH, dilute alkali, will undergo self-addition. That means one molecule will be added to another molecule. That means here we need two molecules of aldehyde or ketone. Then only they will undergo self-addition reaction. So how it will take place? Look at it here. First molecule CH3 C double bond OH. I am writing the first molecule. Then second molecule I am writing CH3. This CH3 can be written as CH2H CHO. Correct? This is alpha hydrogen atom. In the second molecule, this is first molecule and this is second molecule. In the presence of dilute NaOH, dilute alkali, what is happening? You get here. This hydrogen atom will be migrated to oxygen. So this hydrogen atom is shifting to oxygen. Therefore, this will become OH. That time you can see that this double bond, one of the double bonds is breaking from oxygen and will join with this carbon. So what we get? Look at here. We get a structure like this: CH3, this CH3, then CH, this CH, and in this one O, and this H is joined with oxygen, therefore it will become OH. Then this bond is breaking from oxygen and is joining with the CH2. So you get a CH2. What is that? CH. So clear? And you can see that this CO group attached carbon, this is alpha carbon, and next carbon is beta carbon, and in the beta carbon there is a hydroxyl group. So this is a beta hydroxy aldehyde. This is a beta hydroxy aldehyde. This is beta hydroxy aldehyde, and this is known as this is an aldol. Why this is called aldol? You can see that in the same compound there is an aldehyde group. So ALD aldehyde group, and an alcohol group aldol. So beta hydroxyaldehyde, that is an aldol. Now if you take a ketone, so instead of acetaldehyde I am taking a ketone. For example, acetone, CH3CO, CH3, acetone. There also we need two molecules in presence of dilute NaOH. How you can write this one? You write the first molecule CH3, C double bond O. This CH3 can be written here, CH3. Second molecule, how will you write? One of the alpha hydrogen you write like this, then COC. CH3, correct? As we discussed, what is that? This hydrogen will be shifted to oxygen. This bond is breaking from oxygen and will join with carbon. So what we get? We get CH3. Here it is CH3. Here it will become OH, and here it is CH2, CO, CH3. Okay. CO group attack alpha, beta hydroxy ketone. These are all. This is also known as aldol. Okay. Now let us go through the actual mechanism. This is not the mechanism of aldol condensation. Let us go through the mechanism of aldol condensation. It's very important. Mechanism of aldol condensation. Mechanism. Step 1. Step 1. I told you the aldol condensation taking place in presence of dilute alkali. Therefore, the alkali or the base or the alkali, the base removes an alpha hydrogen from the aldehyde, from the aldehyde or ketone to form enolate ion, to form enolate ion. This also we have studied how enolate ion is forming. Look at here. I am taking the first molecule. I told you we need two molecules of aldehyde or two molecules of ketone. I am taking the first molecule of aldehyde. Example CH3, CHO. This is our aldehyde, or you can write CH3 double bond O H. This CH3 can be written as CH2H. Correct? This is the first molecule of aldehyde, CH3, CHO, acetaldehyde I am taking, or example acetaldehyde I am taking. What is the first step? The base removes. If this reaction is taking place in presence of dilute NaOH, that means Na plus is there, OH minus is there. That means the base removes the alpha hydrogen, removes this proton. And what will happen to this bond? This bond, that means a pair of electron. This will go back to carbon. So what we get a structure like this, CH2, and the two electrons are coming to carbon, two electrons, and hence it will get a negative charge. Then what is that? C double bond O H. What is this one? This is what is called enolate ion. This we have studied. Now this enolate ion will be stabilized by resonance. How it will be stabilized? This pair of electron will be shifted to here. So here it will become a double bond. That time the double bond will be shifted to oxygen. So what we get? We get CH2 double bond C. Here it is O minus, and here it is H. This is the resonance stabilization of enolate ion. Okay, this is enolate ion. How enolate ion is forming? This base OH minus removes this proton. Then this bond means a pair of electron is shifting back to carbon. This carbon is getting a pair of electron and a negative charge. This is enolate ion, which can be stabilized by resonance. This pair of electron will be shifted to here. Then one of this double bond is migrating to oxygen. Therefore, oxygen is getting a pair of electron and a negative charge. And this is the resonance stabilization of enolate ion. So the first step is formation of enolate ion. So we have taken one molecule of aldehyde. Now we have one more molecule of aldehyde. Look at it here. Now in the second step, step 2. Step 2. The enolate ion will act as a nucleophile and will attack at the carbonyl carbon of the second molecule. Now look at here. I am taking the second molecule of aldehyde. CH3, C double bond O, H. This is our second molecule. First molecule is changed into enolate ion. Now we are taking the second molecule. This second molecule plus now we in the first step we got enolate ion, that I am writing CH2. Okay, C double bond O, H. This is our enolate ion. Enolate ion formed in the first step. This enolate ion will act as a nucleophile, negatively charged species, and will attack. We know that the CO group is polar group. The C is having slight positive charge and oxygen is having slight negative charge because of the electronegativity difference. Therefore, you must this carbon is slightly positive charge. Therefore, what will happen? This enolate ion, this negatively charged enolate ion will attack on this positively charged carbon. This enolate ion is having a negative charge that will attack on this positively charged carbon. Then what time what will happen? One of the bonds will be shifted to oxygen. So what we get? You get a structure like this: CH3. Here it is CH. This will become O minus because this pair of electron is shifted to oxygen. Of course, O minus or a pair of electron with a negative charge. And what will happen? Since this CH2 is attacking on this carbon, CH2 is joined CH2. What is that? CO or CHO. Clear? Look at it here. CH2 is attached to this carbon. Therefore, CH3, CO minus. Then CH2 is attached. CH2, C double bond or H or CHO. Okay. This is known as alkoxide ion. Alkoxide ion. Okay. The second molecule to form alkoxide ion. This is the second step. The enolate ion will attack the second molecule of the aldehyde, or if you take a ketone, it will attack the second molecule of aldehyde or ketone, and then it will change into alkoxide ion. This is the second step. Now step 3. The alkoxide ion. This alkoxide ion is protonated by a molecule of water to give beta hydroxy aldehyde, which is known as aldol, beta hydroxy aldehyde or aldol. So, what is that? The alkoxide ion. I am writing the alkoxide ion. This is our alkoxide ion. CH3, CH, O minus. What is that? CH2, CHO, C double bond O, H, or you can write CHO, will be protonated by a molecule of water. Okay. So, water molecule present in the reaction mixture. We are taking aqueous or dilute alkali. Therefore, water molecule is present. So, water molecule present in the reaction mixture. Okay, HOH, that means H plus and OH minus. Then what will happen? This O minus will abstract this H plus. Okay, so what will form? We get CH3. This will change into CHOH. Then CH2, C double bond O H plus what will be eliminated? Here the H plus is taken by O minus. Therefore, this bond is shifting to what will happen? Plus OH minus. Now, what is this one? The CO group attached to carbon alpha, beta hydroxy aldehyde, or this is aldol. Plus, what will be generated? Our base is generating. First step, the base is used, and base is there, OH minus, and now you can see that OH minus is regenerated. Okay. This is the formation of beta hydroxy aldehyde. Okay, so aldol. Now there is another part for aldol condensation. because the aldehyde or the aldol thus formed will undergo dehydration, will eliminate water molecule and it will change into alpha, beta, unsaturated aldehyde or ketone. So what is the meaning of that? Look at it here. So continuation of aldol condensation reaction. So look at it here. Now we get the aldol, like the structure of aldol is like this: CH3, CH, OH, CH2, C double bond of H. This is our aldol. This is our aldol. This aldol on heating, what will happen? Look at here. On heating, you can see that will eliminate water molecule. Minus H2O. That means you can see that this one of the alpha hydrogen. Here it is CH2. Actually, it is CH2. I can write CH2 like CH. Then what will be eliminated? H2 will be eliminated. Then here it will form double bond. So what we get? CH3 CH double bond CH single bond CHO. Okay, so here you can see that this carbon is alpha carbon, this carbon is beta carbon. That means alpha, beta, unsaturated aldehyde. This is alpha, beta, unsaturated aldehyde. This is actually the final product of aldol condensation, but we get alpha, beta, unsaturated aldehyde or alpha, beta, unsaturated ketone. Now let us go through the mechanism of this part. Which part? Dehydration part. That means part 2 mechanism. Part 2, what is that? Aldol dehydration. How we get alpha, beta, unsaturated aldehyde or ketone? What is the action mechanism of alpha beta, formation of alpha beta unsaturated aldehyde or ketone? Look at it here. Step 1, part 2, step 1. The base again. The base removes an alpha hydrogen from the aldol to form enolate ion. As in the first part, the same step we are repeating. The base removes alpha hydrogen from the aldol, which was our aldol: CH3, CH, OH, CH2, C double bond of H. This is the aldol which we got in the first part. First part we got aldol. Now in the second part, what is happening? The base removes alpha hydrogen from the aldol. So which is the alpha hydrogen? This is this group attached. This is alpha carbon. The hydrogen atom present on these two hydrogen atoms are alpha hydrogen. So you can write one of the hydrogens. Okay, correct? This is alpha hydrogen. Now again, the base NaOH, OH minus removes this proton. Okay, so what is eliminating? Minus H2O. And what will happen to this bond? This bond is migrating to carbon, and we get a structure like this: CH3, CH, OH. Here it will become CH, a pair of electron and a negative charge, and here it is C double bond of H. What is this one? This is enolate ion. Now you can see that this enolate ion can be stabilized by resonance. How it will be stabilized? This pair of electron will be shifted to here. Then one of the double bonds is migrating to oxygen. So what is the resonance stabilized structure? CH3, CH, OH. Here it is single bond CH. Here it will become double bond CO, a pair of minus, and here it is an H. This is the resonance stabilization of enolate ion. Okay. Now step 2 in part 2. Okay, step 2. So first step, the base removes a alpha hydrogen from the aldol to form enolate ion. Now step 2. Step 2. The enolate ion removes OH group by protonation with water water molecule to give alpha, beta, unsaturated aldehyde, and aldehyde, or if you take ketone, you will get ketone. What is the enolate ion removes the OH group. So I am taking this enolate ion CH3, CH, OH, single bond CH, double bond CO minus H. Okay, the enolate ion removes OH group by protonation with water molecule. Again, another molecule of water, HOH, H plus and OH minus. You can see that this OH group is having a lone pair electron. Oxygen is having a lone pair electron. This lone pair electron will abstract H plus from water. So what will form? Look at here. We get CH3, CH. Here it will become OH and one more OH and H. So it will become OH2, and of course oxygen will get a positive charge. Why it is getting a positive charge? This pair of electron is donated to H plus to make a bond. So here it will become OH2, and I am continuing. Here it is CH double bond CO minus, and here it will become H. And in the next step you can see that, look at here, this pair of electron reverse. This pair of electron will be shifted back. Okay, then here it will become double bond. Then this bond, this CC bond will be shifted to here. Okay, then here it will become double bond. Then what will be eliminated? H2O will be eliminated. So what is eliminating? Minus H2O is eliminated. What is remaining? We get CH3, CH, double bond CH, single bond C, double bond OH. What is this one? Alpha, beta, unsaturated aldehyde. If you take a ketone, you get alpha, beta, unsaturated ketone. So, in the second step, you can see that the enolate ion, this is our enolate ion, in the OH group is removed. This OH group is removed in the form of water molecule. How this OH group is removed? First, the OH group is protonated. A proton is taken by the OH, then it will change into OH2. Then you can see that this pair of electron is coming back. So here it will become double bond. Then this double bond is shifted to here. Here it will become double bond. Then what will be eliminated? H2A is eliminated. Okay. Or you can say that H2A is eliminated. Then this is shifted to here. This bond comes back. Clear? H2A is eliminated. This bond is shifting to here. This pair of electron is coming back. That way also you can explain. Okay. Now that's all about aldol condensation. Clear? Thank you.